of 2. So as long as it's less than selection.count, then go ahead and run this next piece of code. Doing this a little bit differently, I made the look at constraint up here. In this case, what we can do is we can actually make it right inside the if statement. Probably better over here, better way of setting it up. So I'm going to drag this over. Same thing as we did up here with the position constraint. I'm going to create a look at constraint. Just make an instance of it into this variable so that we can just work with this variable instead of having to constantly list all of the paths down to the controller. What we can do is we can just work on this this instance of the controller that we've generated. Again, let's just do a evaluate that line so that look at con is global, and we can do a show. And there's, when I run show on the look at constraint, here are some of the things that we're working with. A few things we need to look at is look at vector length. When Max adds a look at constraint, it puts that big huge blue line that goes on forever. I set that to 0 right away so it doesn't show up. And the other one that we're going to need is upnode world. We want to set to false, and that's using the world as upnode. What we want to do is we want to actually set that to false, and we want to pick the upnode, and we want to set the upnode to be the actual point helper that's at the root of the joint. And then the next thing we want to be able to do is show interfaces, and we need to be able to do the same thing. We need to be able to append the target and the node. So it's exactly the same format for using a look at constraint. It is the position constraint. So on to the adding it then. What we can do is we can say d.rotation.controller equals look at con. And then what we want to do is we want to set the look at con parameters that we need. And I'll just, again, I'll copy and paste this out of here. So what we've got is we append the target. So we set a target. Again, in this case, it's going to be not equal to I. It's not going to be the first one. So if we're working on the first joint, we're not looking at the first point. We're actually looking at the second point. So what I've done, again, this is why we've done the iterative loop here. Index loop, is that what we can say is that the append the target points, and instead of the point that is equal to the joint we're on, we're going to say the joint plus 1. So we're looking at the next point as what it goes, so it looks down to this one. And again, a weight of 100. And then look at vector length. And so to use the use this, it's just look at the controller itself, the look at controller. Dot look at vector length equals 0. That makes that blue line 0 in length. And then upnode world equals false. So we want to use something else. We don't want to have the upnode set to world because that would mean our character could rotate around a world space, and the joints in the face would not rotate with it. Essentially, they'd twist wildly out of control. And we want to set the pick upnode to, again, back to points just I instead of I plus 1, just I. So that's back to the one at the root of the joint again. So now we have is this nice little script for handling our stretchy bones. We should be able to evaluate this whole piece of code, and it won't give us any errors, hopefully. Let's just do it, and you just say it comes out okay. And let's grab this and just delete it again, and let's make a test joint. Select all of it, and we should be able to run make stretchy bones, and it should set us up with a set of point helpers. And if we rotate any one of these point helpers, it'll actually twist the bone. And then when we move the point helpers, they'll actually stay looking at each other and give us stretchy bones. So there's our stretchy bones script, set up very simply and reusable. Now all we need to do is we could just simply create a macro script using this function that calls this function and make sure this function is always loaded in the scripts startup or in the std plugs std scripts folder, which will actually load first. And we could drop it there, and it would be available to us by either command line, just typing this, make stretchy bones, and close parentheses, and it would run it on whatever whenever we have selected. Or of course we can make a button bar out of it and go that route. So why don't we actually do the button bar for this case. I've got a button bar that I use for dropping stuff on. I'm just going to grab this command and drop it on here and just edit the text and stretchy bone. And now I've got a button I can press and have it set up the stretchy bone for me. So now I should be able to go back to our face and go through the process of adding stretchy bones everywhere. So I'm just going to double click on the root, say stretchy bones, and then I've got the setup of point helpers all the way around, and I've got a stretchy bone set up. And if I set up another bone like system like this one, stretchy bones, well, you'll see I've got 2 point helpers here, and again those will eventually get parented into probably a third, maybe even a fourth, to get alignments correct. But now when I move both of these, I get the nice stretching going on. Same thing with setting up all the way around here. You can see that once I pick these two, again I'll have a nice stretchy system set up. So just like when I was grabbing the bones directly, but now it's from the point helpers themselves, and they'll all stay aligned. What I can do is eventually all these will get either parented off to either other point helpers, other control objects, and you know, wired expression into the controls and whatnot to be able to control the face. So I'm going to go ahead and I'm going to finish setting up all the point helpers on the rest of them so that each one of them has a stretchy bone set up and isn't parent to anything, and I'll take it from there when I get back.